and they got screened for content and kicked off. So I'm going through the appeals process with YouTube to get those last 2 videos up there. I'm not sure what I said in class, or I know it's we may have recorded some other conversation beforehand. I don't know.
I accidentally pulled up on YouTube. You'd think it'd be no problem.
I know, right? So I put in a request for them to have an appeal, or at least tell me why if I didn't put it in the right format, or maybe it was too long. You know, maybe I need to split them into shorter segments. I don't know why, but they got kickbacks, and I'm waiting on a response for them. So.
I think 15-year-old checks video real fast.
I don't know. So tonight was functions. So any questions over arrays from the last time? That's what I figured. All right. So tonight we're going to start on doing functions. Go ahead.
Did you get my email yesterday?
Maybe.
I wasn't going to be here.
Probably.
Okay.
I'll have to check. I don't know.
Too late.
Yeah. Problem solved. So moving on to functions. So now that we understand what the arrays do, we have a contiguous amount of data. Now we want to quit typing things over and over again. So I went ahead and made a day 7 example here, and we'll roll through a bunch of examples. But basically we've learned everything we need to do our computations. Now we'd prefer to do the computations once and then call that same item many times. So I'm going to start modularizing my code. So if I can make that bigger so everybody can see a little better, probably.
Okay, I'm sorry. Is that a...
There you go.
well, it'd be good if I get the right language. Did you say CLR?
I just did a Win32.
Windows 32.
But again, these work on both sides, so it doesn't really matter.
Console application.
Console application, there you go. All right, so what we're going to do tonight is just go ahead and we'll start doing some math operations here. So I'm going to do something really simple. So we're going to start doing take a number and squaring it. So I'll just start with an integer because that's basically what to start with, and I'm going to have that equal to 4, and then I'll say start equals start times start, which I would assume that would square that guy. Then I can go ahead and print that out. So I'll put start squared equals, and then start. So in that case there, got that guy printed out. I got a little squiggly line. Again, I need to go and add that include header. In this case, it's IOStream. Add that in there. That squiggly line should go away. So if I go ahead and run that, I should get a very simple little program here. Maybe. Of course, we've got the fast computers here at Rose State, so it does take a minute. Oops. Don't run it in debugger. You can't see the output. So now I'll run it without debugging, so I can just see the output. And there I got start squared is 16. I need to go ahead and add a new line in there. That way it goes to the next line. So I'll do an std ENDL. So in this case, I took the integer 4, I squared it, and I printed the result there. Well, let's say I wanted to do that again. I could take another integer, start number 2, and have that equal to, say, 8. Then I say start 2 equals start 2 times start 2. Now again, this is a real trivial example here because we could probably do that math in our head. However, we're going to use this to reinforce the concept of having functions and re-executable code. So here, I've got 2 options there. One's 4, one's 8. I square both of those numbers and print them out. Looking there at the results, should end up with a 16 and a 64. Awesome. One thing I'm going to do is add in one more inline. So now there I've got 2 squared functions, and it'd be really nice to have some way to just write this code once and then use it multiple times. So I can do that with what's called a function. A function comes from that same term in math, to where an f of x equals y. So if I pass this function a certain number of parameters, I will get a result back, and that should work the same way every time. So if I give it the same input, I generate the same output, which is the concept of a function. So what I'm going to do here is I'm going to come up here to the top, and I'm going to write me a new function. So a function starts with, has three things in it. One of those is a return type. So what's this guy going to return? In this case, I'm going to do a void, which means I'm not going to return anything. It's one of those keywords we haven't really seen yet. So I'm not going to return anything. And I'm going to call this square number. So in this case, I've got this function called square number. And then in here, I could put the same thing I have there, and start equals 4. And then I would have start equals start times start. And then cout. Do a little cut and paste there. So in this case, we've actually written ourselves a function. This tells the compiler, hey, we've got a function written here. The next time you see this squared number followed by parentheses, we know what to do when we see that identifier. So in this case, I can replace what I have down here in main with that call to square number. So I can replace all of these items. And now instead of doing those 3 lines, now I will just call square number. Now when I invoke that function, to invoke it, I use the same name followed by open close parentheses, and I pass it whatever is between parentheses. In this case, I have none, so I have none here. So this I would expect to get the exact same answer we had before. So again, if I go up there to debug, start without debugging, let my awesome compiler run, and there I get start squared as 16, and the other one is 64. So there's a way that we've invoked a function. We've set some code up here. We've invoked it and ran it. The nice thing about a function is I can call it many times and write it only once. So in this case here, if I wanted to do square number, and I wanted to call it 3 times, I would just call that one item 3 times. It would then do everything in that function, come back, do the next one, everything in that function, come back, and do the next one. So in this case, I should get that same function call done 3 times. Go ahead and do a start without debugging there. And again, I get start squared equals 16, 16, and 16. Okay, convenient. However, you say, well, that's not so helpful. I now have start down here being 8. So I now need to write another function that has 8 in it to square it. So what would really be nice is if I could alter what was being used inside that function. Well, just like your f of x equals y in math, I can actually pass it some parameters. So now I can actually come up here and I can modify this function. So now we're going to modify a square function. Actually, I'm going to give it another one. I'm going to write a new function called void square number. And this time, I'm going to pass it a parameter. I'm going to say that you're going to give me, when you call this, what the start value is. And in this case, I'll take start equals start times start, and std cout. Start squared equals start slash n. So now here in this case, I've written a second function. This function is called square number as well, but it takes a parameter. So now I can pass into it a value. It will take the value I give it, multiply it by itself, and print out that same cout statement. Now in order to invoke this function on line 14, I now have to describe the variable, the function name, followed by the variables that we're going to pass to it. So when we call that first function, we just called square number with nothing inside of it. Well, this time I'd like to use 8. So this time I'm going to comment out lines 29, 30, and 31. And so this time we're just going to call that square number. And now I usually even get the IntelliSense that tells me you've got two different options for this function. One that takes no parameters. I can hit the down or up arrows and it gives me my other option. Or one that takes a parameter of an integer value. So in this case, let's pass it start2. So now I've commented out what we had before. Now I'm calling a square number, and now I'm passing it a value. So it's going to call that second function, and we presume that we're going to get the same result. Go ahead and do start without debugging, pops up, and there I get start squared equals 64. So now we're able to use a function and call it with a variable. Allows it to use that variable and then give us a different result based on the variable that we started with. So, questions there so far? Alright, so just like inside of a math problem, a function should do one and only one thing. You give it one thing, it passes you back something else. So in this case, I have this function called square number, but I'm actually doing two things in there. I'm squaring the number and printing it out. So, and if I wanted to square a number and not get it printed out, I would have to write yet another function, because this function every time prints out the number as well. So one thing to keep in mind is when you write functions and you're trying to make them modular, if you say a function does this, it should do that and only that, and don't add in the extra stuff in order to make it do anything else. So in this case, we've passed it. We've got these three function calls. I'll comment those out for now because I only want to call that once. Comment it out. I can just do a double forward slash. As in down here, I did a forward slash and a star, which is a multi-line comment. So now I've taken start2 and I've had it equal to 8. I print it out. And now when I'm done, I'd like to see what's inside of start2. So if I print out start2, I can now do start2 is now, and I want to print out one more before the function call. And of course, I'm going to add me another new line on there. So in this case, I'm now going to see what start2 is before I make the call and what start2 is after I make the call. So again, I go ahead and run this guy. I would presume that I would start with it being 8. I call the squared function. I get 64. And when I'm done, I get an 8. Well, that is because we have what's called a pass-by-value operation happening here. So in a pass-by-value, you actually give a copy of what you have to the function. It does whatever it wants with that copy. And then when that function is done, you still have the original. So in this case, even though these were both called, this was called start, when I passed it in, this guy received a copy. It made some changes to it. Again, we took start times equals start, put it back in there, and then printed out the result. And then when I came back, what I passed it was still the same. That is a pass by value. However, I could say that I want to give you the original. Well, that's called a pass by reference. In order to do a pass by reference, what I need to do is add the reference operator to this value. So, if I was to make that one small change and make square number now take a integer address, or the address operator of start, I am then passing it in by value, which means I'm not giving you a copy, I'm giving you the original, and when you're done, give me the original back. So, in this case, I go to run this, and hopefully it's what you expect. So in this case, start2 was 8 before the call. I squared it to get 64, and now after the call, start2 is now 64. Because again, we had an agreement. We said, hey, I'm going to give to you the value, give to you my original. You do what you want with it, and when you give it back, I will take it back and use that. So down here, even though we didn't see that start2 changed, but start2 did change because this square number actually changed it. If that happens and you don't want it to happen, that's called a side effect. I didn't quite expect that to happen. I didn't really want you to square that guy. So one thing we can do is we can update our interface to say, I'm going to pass this in there by reference. However, I don't want you to change it, which means I want to make this guy constant. So I'm going to give you the original, but we're going to make an agreement. You're not going to change it. Well, as soon as I did that, the compiler said, hey, wait a minute here. I found the same variable on the left side of an assignment operator, which means you're going to end up changing this guy. So I need you to either change the const or change how you're doing the business. So in this case, I can say, okay, you're right, and start2 and 2. So now in this case, I pass it in a value. I then make a local copy of these two multiplied together, and then I print out what the result was. And now when I return back, even though I pass it in by reference, I now have an agreement and said, hey, you can't change this guy in there, so I should get back the same result that I started with. And again, I can verify that, go ahead and running it, and again, I passed in 8, I got 64. When it came back, I was back to 8 because there was no changes that were made. Yes, sir?
Is there a reason to do that instead of just saying int start so that you create a local variable that dies at the end of it?
If I created int start where?
Like if instead of doing const int dereference start, just say int start.
Okay, well, like we did from the beginning.
Right.
So what that does, that makes a copy. And you think, well, that's not too big of a deal. However, the more copies of data that I make, the more memory I use. So in this instance, it's not that big deal at all. It's one integer, you have one, I have one, not too big a deal. The big deal will come in is when I have this large structure of variables, or a large structure of data, and I'm going to let you use it. So when I let you use it, I'm going to say, hey, I'm going to just give you my whole copy. And matter of fact, I'm going to give you the original because I don't want to give you a copy. But now when I give you the copy, I want to make an agreement that you're not going to change it. Because I just want you to use it.
How does this one not make the note, or does the start2 die as soon as this is done?
Start2 dies as soon as it's done.
Okay, so that's how this one's better, is because what it makes dies right at the end.
Correct.
Okay.
So what I could really do is I could get rid of this variable and just put start times start in here. But then we wouldn't have the example of using a reference. So here's an example. I'm actually making an agreement. This guy's going to be constant on the way through there. So this, guys, what's here is called a function definition. I've declared the function. And just like integer, or just like variables, I have to declare a function before I use it. So let's say I did something crazy. I'm going to cut and paste this code and put it down at the end. So down here at the end, again, I have no squiggly lines. Everybody says everything's good there. I go ahead and go to build it. It comes up and goes, oh, wait a minute here. It says square function does not take one argument.
You need a prototype.
Well, I have to be able to tell the compiler that, hey, I declared a function that you haven't seen yet. It's down below or it's coming. But yeah, I know you're going to run into it. So if you're going to declare your functions after you use them, you have to have what's called a function prototype or a function signature. So a function signature consists of the function return type, the function name, and the parameters, followed by a semicolon. So what that says is, hey, compiler, if you see a function call that takes these types of parameters, I owe you one. And then it's up to you to provide it before the linking stage of the compiler. So now we've pretty much given here an IOU. And the other thing that you can do with function prototypes is you don't have to specify the variable names. So I could actually just say, here's the data type I'm passing, not tell you what the name's going to be. Because again, this is just a promise saying that I owe you a function definition. So when you see this function signature, just accept it. So again, in this case, I do Control-C, I go hit build, and now I don't have any problems. Because again, we said, hey, it's coming, and then if I go look down at the bottom, I actually provided it. Now, you got to make sure your function definition matches your function header. So if I go make a change in here and say, you know, we want to go back to what we had before, and I don't want that to be a constant. Okay, no problem. I go back to my build, and then I should get an error. It goes, hey, wait a minute here. This first line here says, you owed me this function that took an integer constant, and I never found it. I've got a linking problem. You say, oh, that's the reason that you can't find it is because the signatures don't match. Whereas up here we said it was going to be a constant. Down there it was not. Those are two different data signatures. So if I put const back on this guy, now the signatures match. I go hit build, and then it builds. Questions there?
So you had just moved that down.
I did, yep. I did a great old cut and paste. So if I can do that with plain old data types, I could also do that with arrays. So if I'm going to do that with an array, let's say I come in here and I'm going to go here to the end, and now I'm going to create a double array of, let's say, 5 pieces of data. So there's my data array, and I can say my data 2 equals 4.3, my data 4 equals 2.7, whatever you like. So now I'd like to know what is the largest number in that array. Well, I could sit in here and write my code in here, but I'm going to think about this and go, I'm going to use this code later. So I'm going to go ahead and write me a function that accepts an array and returns back the highest number of that array. This might be helpful for you to later. I don't know. So in this case, well, I'm going to call this function, and let's call it something meaningful like find max number. And then I'm going to pass it my data. And let's say I say that's what I want it to be. So of course I get my squiggly line, and what's the squiggly line tell me? I've now found this function call, which I haven't seen before. So you need to give me a function prototype, or declare it before you use it. So I come up here, and I do void find, can't remember what it was. I do a copy and paste, magic number, and this takes a double array. Now, if I did it like this, I would think, hey, that's going to work out great. However, what I did is I said this guy would be an array of data, not just one item. So now I've got to come back to the top and go, oh, that's going to be an array of data. So now I get my little curly brace to go away. I think, oh, I should be done. However, I made the compiler a promise. Here's what my function you're going to run into, and I promise to provide it before the end. So I've declared it at the top as a prototype. I've invoked it here on line 37. I now need to define it. So I'll define it here. So I'll call it find max number, and of course it took a double array braces. So there's a complete function there. This is what's called a function stub. I haven't written any code in there, but I've made my main function work, even though my stub does not have any code in it yet. That way I keep compilable code as I go. So I make sure my code stays compilable as I write it. So in this case, I want to find the maximum number. Well, how do I find the maximum number in an array list?
You start off by making slot 0 of the array your biggest number, then you look at slot 2, see if it's bigger than slot 1.
Let's give it a shot. So we said we passed in an array of doubles. So I guess I need to declare a max value and have that equal to what? The first spot?
Yeah.
So the first spot. And then now I need to look through all of my items and determine if this guy is less than that. So if I was going to do a loop, I'd probably want to use some sort of for loop. So if I do a for, I'm going to do a for each this time. Do a for each, hit enter. It says, oh, hey, by the way, if you actually hit enter, it fills in what you want for you to go ahead and change. So in this case, this is the object we're going to call it while it's in here. And the variable name can be var, or whatever variable you'd like to call it. And then what are we looking through? Let's say I want to look through the array. So now in this case, I could process it. Say again? Well, there's actually another problem here, because I got an email about this earlier, so I was going to throw it out there. So I've got this for each loop, right? And it says double var in, and then here's what I want to look at. I want to look inside of this array. But I get this squiggly line. Well, what's a squiggly line mean? Well, if I scroll over it, yes, it means an error. If I scroll over it, it says name of collection or array to iterate through. And it says a for each loop cannot iterate on an expression of a double bracket. Well, the reason for that is this for each loop is based on a standard library template, and this for each loop needs to accept some sort of collection. Because this double array is just a array, it's not going to like it. So I'm going to change this to a for loop, and we'll talk about this for each loop when we get to chapter 8 on the standard template library. It'll make a lot more sense then. So I'm going to go ahead and back out of that guy. And now we'll do it the old-fashioned way. So we'll say integer I equals 0, I is less than array. Uh-oh, now we have a problem. How far are we going? How do we know how big this array is? Well, there's some ideas. We talked about a couple of them last time. Array.length. So let's try array.length, see if that would work. Of course, I get the great squiggly line there because there is no dot length in that array because this is an internal array. So I don't get a dot length. So close. So somebody might think about what we talked about last time and goes, well, wait a minute. There's a little trick that I could probably do. I could probably say size of array divided by size of array 0. That might be a way. And we'll see why this won't work. But we got size array, how big the array actually is, divided by size of the first element. If I take the total list divided by how much each size contains, I should get a quantity. So in this case, I would expect to get the number 5. So then in here, once I'm inside of this array, taking the suggestion we got, if max is less than array I, max equals array I. So now that I get done with this loop, I then need to somehow tell somebody what the answer is. Well, in this case, we declared this function to return nothing. Well, in this case, we actually want to return something. So if I change this return value to what I want to return, in this case, double, I should get a squiggly line here. One squiggly line because it doesn't match my prototype at the top. So because I changed it on line 42, I'm going to go change it on line 14. And then my next squiggly line should come in down here because I'm not returning the right data type. So now instead of returning nothing, this time I want to return max. So now here's a way for us to find the maximum number of this array. Makes sense? Huh? If I was talking about a pointer, maybe. But because we've declared in our definition that this will be an array of data, you can treat that as an array of data.
What did you have for that at the top?
Sure. So I have to make sure that what's on line 14 matches what's on line 42, except for the fact that this guy went in with a semicolon. We won't define it at the top. We'll just declare it as a prototype. It's okay.
You went back down.
Oh, I did. There you go.
Find max double or
Find max number, open parentheses, and then a double array. So now in this case, I'm calling it. I'm actually invoking that function on line 37. So if I go and run this, I go to debug, start without debugging, let it go through its stuff, and I don't see any output. I was like, well, I called the function, I don't see any output, why not? Well, I called the function find max number. It returns back the number, but I didn't do anything with it. So let's go ahead and print it out. So I'm going to encapsulate this inside of a print statement. And then, of course, I'm going to add in a /n at the end to make sure it prints out on a new line. So now we're actually printing out the max number that we found. Let's see what it looks like. So we went through, and the max number was 0. And I'm like, that is exactly what I hoped for, right? Not so much. I specifically put a number in there, 4.3 and 2.7. It found 0. So let's use the debugger, because I don't really see right now what the problem is. So let's go use the debugger and see if the debugger can help us. So to do this, I'm going to scroll down here where I'd like to stop the debugger at. And in this case, I'm going to stop it over here. If I click over here in this column, it puts in a dot, a red dot, which means that's where that guy is going to stop at whenever you run it. So now I'm going to actually start debugging with this guy. And now it's stopped on this line. Here's what we're currently looking at. And I can see some things here. One of those is autos, which means here's what I'm declaring inside of this function. Here's my call stack. Here's where it was called from and where I currently am inside my execution. And then now I have these extra commands at the top. These guys right here. These guys are what lets me step through the code line by line. So right now in max, I've got this negative 9.255 e to the 61st power. Why does max have that in it?
That's just where the memory happened to
Right.
reside.
I'm on this line. I haven't executed this line yet, so I haven't done an assignment. So this is just what's currently in it. So I'm going to go up here and I'm going to hit step over. There's 3 items, step over and step into. So I'm going to step over, which goes to the next line, indicated by my arrow. So down here inside of my max, you can see that I now got an updated value of 0, 0, 0, 0. And now I, which we're about to see, again, this line hasn't executed yet, so I is still jump variable from memory. And now I've got this size of array and size of array 0. So now if I hit the step over button, I can tell that I ended up to be 0. And now I'm down here to line 50, where it returned max. I never even got into this for loop. Well, why is that? How come I couldn't even get into that for loop? Well, the reason I can't get into that for loop is because apparently I was less than these 2 values. So what are those 2 values? Well, so in this case, I'm going to come and create some variables here. And I'm going to call this one size of size whole equals size of array. And then int size part equals size of part. So now in this case, I've now changed some code. What I like to do is I like to go ahead and recompile this and start over, because I can't really go back up. So I'm going to come up here to this restart button here, and that says, hey, go ahead and restart this debugging session. It still keeps my breakpoint in the same spot, but now I should have some new code. So now I've got this size hole and size part as part of my code. So again, to step over, I click on the step over button, which is, I believe, that first one. Nope, it's the second one, step over. And now I'm on size hole. I hit step over. It says size hole was of size 4. So it said the whole length of my array was 4. I do step over again. It says the size of that one part was 8. And then, of course, 4 divided by 8 is 0.5. Round it off to an integer. I should get a 0. Is 0 less than 0? No, it's not. Doesn't even execute in my for loop. And I say, well, that's really weird. Why did those guys return those values? So I'm going to go ahead and do something totally crazy. I'm going to take these same variables, I'm going to copy them, and I'm going to put them right up here. In this case, I'm going to do the same thing on my data. So now in this case, I want to see what my data is before I actually call it, to see if it's messed up or not. So I save that. I go ahead and go back to my debug. And first, I'm going to put in a break statement on line 37. Go ahead and hit stop debugging and start debugging. It recompiles for me because I added code. And now I'm on line 37. I can see down here that it actually provides me the data I'm looking for. I do a step over, and now when I make this call, I get a size part of 8 and a size hole of 40. I think, well, it's 5 long. Each one's 8 long. 8 times 5, 40. Boom, works out good. Well, now on this line, I'm going to do what's called a step into. So I want to actually go into that function. So now instead of step over, I'll step into. And now I came into that function. So now I'm on this line. And now I'll do a step over, which is actually where my next breakpoint was anyway. And now I walk through those two, and I end up with 8 and 4 again. I go, man, that makes no sense to me at all. Anybody got any ideas? All right, so I'll tell you. Say again? Yeah? All right, so I'll go ahead and throw it out there. So the size of operator, they showed you this in chapter 4 and said, man, this was a great idea. If you just take the length of your array divided by one element, you'll know exactly how long those guys are. However, that is a compile time option, not a runtime option. So I could call find max number as many times as I wanted with as many different length arrays as I wanted. And you don't know which one you're going to get called until runtime. So at compile time, size of operator says, oh, well, at this point I don't really know how long it is. It's going to at least be 1 integer long or 1 address long. So it gave me back a 4, which is wrong, right? That guy really should be 40. So what most people will do is when they're passing in an array, they're also going to pass a second parameter of the size. And this is why. Because that size operator doesn't really work as promised. It works at compile time, not at runtime. So if I use an array that wasn't declared in the same spot I use size of, it's going to give me data I don't expect. So in this case, what I need to do is in find max number, I need to also pass it a second parameter. I need to pass it in a length. So I'm going to erase these two guys, and I'm going to modify my header here, and I'm going to say, hey, I want to pass into you a length. Now, of course, when I make this change, I've got a few problems. The first problem is, one, it doesn't match my prototype. So I'm going to hit stop debugging here. I'm going to go up here to my prototype. Now that I've added in another one, I need to add in an integer on the prototype. And now I should get a squiggly line here because now this find max number doesn't take just one parameter. Now it takes two. So in this case, I now need to give it a 5 as well. So now we're calling this function with two parameters, one being my data and one being a 5. I then come down here, and instead of using this great idea we had of the size of operator from the last chapter, I'm now going to use length. Sir?
If you were to pass instead of 5, you were to do that fancy size of my data over size of my data 0, that would go correct?
Correct.
In case you change your array later on?
Correct. That is correct. So now in this case, if I go ahead and run it, I hope to get a better answer. Start without debugging, which means ignore my break statements, and now I got the max is 4.3. So now I got what I did expect of 4.3. So now in this case, just looking at the data that we have here, I'm passing in an array, and I'm passing in an integer. However, in here, I don't make any changes to those. So instead of making a copy, I'm actually going to give you the actual value, so we don't have to make a copy. So I'm going to add an ampersand to that guy. When I add an ampersand to that one, I need to add an ampersand to the function prototype. So now in this case, I can now pass in an ampersand. And now I'm not actually making a copy. I'm actually giving you the value, you're using it, and then we don't have to have copies everywhere. Any questions there over find max and the number? Get rid of those breakpoints. Just click on them again, and then they go away.
This part two that you got, the double my data 5, how does that relate to these two?
Okay, so on line 34 here, we're actually declaring a variable called my data. That's going to be of type double, and it's going to be a contiguous block of memory of 5 items. So that actually makes me 5 items that I'm going to refer to from my data. They're going to be doubles. So that gives me 5 doubles. And I can refer to those using indexes 0 through 4 because C++ is 0 indexed. So I can say my data 0, my data 1, my data 2, 3, and 4.
So that is the arrays that you're
That is the array that we're passing in. Yes, sir.
Yeah, I'm getting an error message on one line.
Okay.
It's
You might want to look.
yeah.
Sure, it's something simple. Where's the problem? That is a linking problem. Says cannot find max number double star constant. Let's roll back to the top. So in this case, on line 15, you've added an ampersand. So now my definition, keep going down, has to have an ampersand as well, because those have to match. No, not a semicolon, an ampersand after the int.
Okay.
Those have to, because that's the agreement you're making at the top that these are going to match. Yep.
Can you make an entire array constant? I mean, just declare the array constant from the very beginning of that word?
Let's give it a shot. So where would I do that at? If I wanted this constant to not change.
I would think const double my data 5.
Line 34, right? When I add the const modifier, I have to do that at the declaration time. So I have to do that there. And of course that means on line 34, the only way I can initialize that is on this same line. And that's why I now get squiggly lines under 35 and 36, because you're now violating the constness of that array. Make sense?
Yeah, it just hit me that I should probably do that because I got like 800 things that don't need to change.
Correct.
Can
Sir?
I see more of line 39 over?
Line 39, sure. It's just another printout there.
Oh, okay.
So on mine here, I now have a squiggly line under 5. Any idea what that means?
Are you still passing it an integer?
I am still passing in an integer. It says that value to reference must be an L value. Well, what is 5 right now? 5 was what's called an R value, which means that we use it once and throw it away. It doesn't exist in memory. What I'm saying down here on 44 is, hey, pass me the address of that integer. And this is saying that, well, what you're passing it doesn't have an address. It's an R value. We throw it away when we're done. So in this case, to make this work, I would need size equals 5. And then here I would pass in size. So now in this case, my squiggly line goes away, because now I can actually pass in the integer value of size. So you say, well, you know what? I really don't need that value anymore. That value is going to go away. So you know what? What I really did is I wanted to have that option. So I'm going to remove that. And I really want to have a 5 here. So how do I fix this? How do I tell it, just take what I give you and use it down here? Well, we determined that this is going to be an R value, right? So now I got to tell it this should accept an R value. So to do an R value, I'm going to do a double ampersand. And of course, on line 45, that's a double ampersand. What am I going to do at the top? Make it match double ampersand. So now all my squiggly lines go away. And now I'm saying that this function accepts an R value as a parameter. Make sense? All right, so now just for giggles, let's I'm going to uncomment that int size equals 5 and try and call the same function again. So now in this case, I'm trying to call find max number. And what's my problem? Again, we've told it, hey, wait a minute. You said the function you have takes a double array and an R value reference. You're not giving me an R value reference. You're giving me an L value reference. That guy actually exists. So if I wanted this to work, I would need to write another function that accepted these types of parameters. So to do that, again, I could just go to the top, and I would declare at the top what I'm trying to define. In this case, I'm going to use the exact same name, except now it's going to take 1 ampersand, which means we're going to pass it in by address. It must be an L value. And I'm come down here to the bottom. I'm going to copy all this, paste it, and just take off an ampersand. So now I've got 2 functions in here. Both of them are called find max number. They both take 2 parameters, but the parameters are different. If I have a function with the same name with different parameters, it's called function overloading, which means I have a function with the same name, different number of parameters. So there's different ways to call the same function. So in this case, I'm passing an R value. In this case, I'm passing in a L value reference. So there's an R value and an L value. So if I pass these guys in as an array, I could almost do the same thing, but pass in a pointer. So if I wanted to pass in a pointer, I could do the same thing. But up here, I'm going to say, all right, now instead of being a double bracket, now it's going to be a double star. So now instead of passing in an array, now I'm going to pass in a pointer, which means here's the memory address of the first guy. And just for giggles, I'm going to copy and paste because I'm really lazy. And I'll put this guy in there. But now this time, I'm going to change my method definition to now be a pointer and an L value. Now in this case, as you can see, because I made this a pointer, the code still works. How come I have no red squiggly lines?
Because the name of an array without a bracket references the memory address of the first location of the array.
Because a pointer is just the first element of an array. So I can treat those the same as if they were an array, or I could use the pointer notation. So if I wanted to use the pointer notation, it looks something like this. I would change this to be a star array, so give it to the first guy. And then how would I iterate through these guys? Well, max array plus I. Not plus 1, plus I. So that'd be a way using a pointer arithmetic to do the exact same thing. Questions there? Yes, sir?
I'm still in the same route. I think when we got mad at the time, it still didn't fix it.
Still didn't fix it? Let's see what you got.
It's like, I'm still working. This is the main one.
Scroll up and see how you called it. So scroll down some. So right there we call find max number. We pass it in a data find. Okay, scroll down some. So then I find this one. That looks good. Then I find that one. That looks good. Do a make a build clean. Tell it to start over. I have to do a build again.
Oh, it's easy.
Yeah.
Okay.
All right. So now we've got an example here with a pointer. I've got one with an array. I've got one with an ampersand. And I've got one with an R value or a double ampersand. Questions there?
So
Yes,
with
sir?
the pointer notation, it's not a copy, it is the actual memory address.
Correct.
So you're messing with the original.
Correct.
Okay.
Same thing with a double. In this case, even though I don't have an ampersand on there, does not make a copy. That's a bit of a fallacy. You say, oh, well, if I put an ampersand on there, I can pass that guy by reference. Well, it doesn't pass every element of the array. It only passes the first guy. So this is where I would need to use my const correctness there. So if I didn't want that guy to change, I could add in the const keyword and say, hey, don't change what it points to. Matter of fact, don't change anything about it, so don't change the data in there either. So if I wanted to use the double const there, which means I want you to constantly point to a double, and I want those doubles to be constant, I could add that in. However, when I change this on line 48, where else would I have to change it at?
Like 15.
Up there at the top when I had my function prototype, because those have to match. So I'll delete those back out of there. That way it still compiles. And there's us calling 3 different types of functions, about 4 different ways, some with and some without modifiers. Same thing with this last parameter. And here I never change it, so I would probably want to make that guy a const as well. Because again, don't change anything, just use it. Because all we're doing is finding the max. Questions there? All right, so back here at the top, on line 7 here, this is a function definition. Because I've defined it before I've used it, I don't need a prototype. However, because I'm defining these later, these have to have a prototype in order for us to use it. It's just an agreement between you and the compiler saying, hey, I'm going to owe you these guys. I promise to give them to you at some point. So now what I'm going to do is I'm going to say, you know what? I'm going to put all that great stuff that we just did in its own file. So in order to do that, I come over here to my Solution Explorer. And I'm going to add in a new one. Add a new item. And it's going to be a CPP file. And let's say we'll call that my functions or whatever you want to call it. Doesn't really matter. But I want to make that a .cpp file that's going to have source code in it. I'm going to go ahead and hit add. And now I've got this extra item added in there. And in this case, I've got this day 7 example. I've got this what I had before, and now I've got this my functions in there. So in this case, I am going to copy all of these guys out of here, and I'm going to put them in that CPP file.
That'll make your code more readable, really.
It will. So copy those out, paste those guys in there. So now I've got a CPP file here all by itself that all it does is contains those functions that we had. And then if I need to make a change, I change it here and not over there. This gave me a bit of abstraction. It separated some code out. So now I could have some people working on this part, some other people working on a different part, because now they're separated. However, over here, I've still got to have in these function prototypes saying, here's what's coming. So let me go ahead and try to compile this and see what it does. When I look down here at the bottom, I should see that it compiles one of them, then it compiles the other one. I didn't get to see the build. Let me see if I can go back to the build. So here in the build, it says, okay, let me go ahead and try to make this guy. So first it does my functions. So what it does my functions by itself. So my functions by itself, what does it need? Well, looking in here, my functions by itself, I've added in this stdc out. So what does this file need in order to work? It's got to have IOStream, right? Because I've added a dependency in this set of code. So let's say I just do something naive here. And I say, okay, I'll do include, and we'll do IOStream. Of course, now when I scroll down, that makes my squiggly line go away. Go ahead and hit build. Look down here. Again, it builds the first one. Now I got the second one here. It says already has a body. Let's go find max number. It's inside of here. Already has a body. All right. Let's go see what I didn't do there. Okay. So it already has a body because I went to compile my functions, and then I go to compile day 7 example, and I put them together, and it says, hey, I've already seen this guy already. I don't want to see it twice. Because once I see it twice, I go, well, I don't know what this guy is because I've seen it once. Then I open up day 7, I've seen it again. So now what I can do is instead of having this functions.cpp, I'm also going to have a functions.h and put those headers in there. So now I'm going to take and move these guys and put them in their own .h file. So to do that, I can come to Solution Explorer, right-click, add a new item. This will be a header file. And the common practice inside the language is whatever my CPP file is called, I'll also call the same name with a .h, so I know that those two files go together.
I'm sorry, what do you,
Go ahead.
when you go on the header file, and you say new item?
Yep, sure did. And then I got two options there for Visual C++. I click on the .h one. I hit add. So now it put that in the right spot under the H's. So now my number of files is going up. So now in this guy, I'm going to move my function prototypes and put those inside the .h file.
So since it's part of the same project, you don't need to like pound include myfunctions.cpp or anything like that.
Not yet.
Not yet.
You'd think that.
Yeah.
Yeah, well, we're going to come to that here in a second. So now I hit build solution. And now, of course, I get a whole bunch of problems. Because again, when it compiles these guys, it compiles each CPP file independently. and then puts all those results together. So now I have to say, okay, how do I tell day 7 example that these guys exist? So again, in here, I'm going to use, again, the include, but this time I'm going to use a quote. And a quote means this is it was either generated in this project or generated somewhere else other than this standard. So in this case, I can just add in my functions. So now I do my functions. And just to help myself out, I'm going to copy square and put that in there as well. So I'm going to come in here. I'm going to go to the bottom, add in square. And then, of course, I'm going to add the function prototype for square into here. Now I got those guys. Let's see what it does now. Rebuild solution. Should be down to 1 error, and it already has a body. Where's that error coming from? Already has a body. That's what I thought. It doesn't have a body. You didn't tell me it didn't. I bet there's a compiler flag I got to set for that R value. Well, I will figure that one out for you. Now, I'll have to look up that compiler option. By adding in that R value from this one and putting in a separate file, it doesn't know which one to grab. So I will comment out that guy just so we can make it work. And I will look up that compiler option for you. So again, build solution. It goes and builds. Problem with that one too. So now I'm getting a previous definition of find max number. So where did it get previously defined at? So I've got this myfunctions.h, which says here's where the items are. I've got this myfunctions.cpp and this day 7 example. And the problem and the error we're getting is it's already been defined and it has a previous definition. So why am I getting it twice? No ideas? Okay, first thing to do is to do a clean. Make sure you clean the whole thing out and try again to make sure you haven't done anything crazy. Then run it again, and I start getting that same error again. And the reason for that is when I compile this both .cpps, what I need to have is what's called include guards. I need to stop it from including it more than one time. In order to do that, I can do that with 2 different ways. One of those is using a pragma statement, and one of those using another preprocessor statement. So I'll show you both ways to do that. Visual Studio's way of doing this is to use a pragma statement, pound pragma, pragma once. Pound pragma once means when you see this guy, only use it once, which means don't include it again. This is a Visual Studio specific compiler option, so this does not work cross-compiler. So if I go run this on Linux or Mac, this is not guaranteed to work. This is a specific Visual Studio option. But pragma once will stop this guy from being included more than once. So in this case, I go ahead and hit build. Comes back up, and I get that stupid error again because I don't like you. Stupid compiler option. Let me comment this one out so we can see the pragma once work. Alright, so now in this case, pragma once said, okay, I'm only going to include this either in the CPP or in this CPP, but once it sees it, it'll only do it once. Now, because this is a Visual Studio specific example, the other alternative to that is using the if not defines, and then I pretty much just do the same function name. Then I do a define. You will see these more than you'll see the pragma onces unless you only stay on Visual Studio. So in this case, this is doing the same way. This is what's called an include guard, which says only include this guy one time. So if this hasn't been defined by the preprocessor, I'm defining from here to the very end. Here's my function prototypes. And then when I include this in my functions.cpp, it'll find it once. When I include it here, it only finds it once because I've had those include guards in. Now in Visual Studio, you can use either one. Most people who only do Visual Studio will just use the pragma once. If you have a guy that does multiple platforms, you'll see everybody using these two because this works on more than just Visual Studio. So it doesn't matter which way you do it, as long as you do one of those. Questions there?
Is there any way to do like all your includes on one, like just the .h's, or you gotta do them in CPPs? Or?
Yes, there is kind of a way to do that, and that's what's called that standard AFX one. So what this says is here's all the include files that I'm going to pre-compile. That way they're available in everybody. Now the issue you'll have with that is if I move this myfunctions.cpp to another project, I have to make sure I update the AFX file in that one and move the .h file as well. So it's common practice to only put in here usually what are going to be standard headers like IOStream, IOmanip, CMath, and those guys would go in here. And then every time I used myfunction.cpp, I would always take myfunction.h because that's what it's a part of. Any other questions? Well, that's Chapter 5. That's everything that Chapter 5 covered, just, in a short nutshell there. So that the things to keep in mind, the whole point of functions is I can write a module once and call it multiple times. I have to make sure that each function has its own unique signature. So in this case, I can have the same name with different types of parameters. That's called function overloading. I just have to be specific on what I'm passing in. These two cases were an array. This was just one integer. This case it was a pointer. If I use the ampersand, that means I'm passing the address of it, which means I'm passing it by reference. So if something changes it in there, I'll get those side effects back. If I want to limit that, I'll use the const keyword. If I pass something by an R value, which is a C++ 11 feature, I use the double ampersands, which means pass this guy by R value. And then I have a return type. That return type can be any type that you have, as well as void. Void means I return nothing. If I want to return more than one item, the only way to do that is to pass it back through the parameters by passing them by reference. So that's sometimes I'll have what's called in parameters and out parameters. In parameters, things I'm passing in that I don't expect to change. Out parameters, I pass in a variable. This function will fill it up with something when the function's done. And I can do that by passing it in by reference, because that's how it would work. And then I would want to keep my code separated. So I've got this list of CPPs, which has all of my code in it. Of course, if I have my function prototypes, I'll put those in a .h file. And then if I want to make sure they're only included once, I have to protect them with include guards. The Visual Studio way is using a pragma once, but that is a Visual Studio compiler specific. Everybody else will use a if not defined defines. Make sure if you have an if not defined, you have an indif to go with it. If not, the preprocessor will tell you that it has problems and quit. A common practice is to use an underscore before and after the name of the function that's called. Sometimes we'll even put this in all capitals. Most macros are in all caps. So it would be an even more common programming practice to put myfunction.h inside of capital letters. So with that, that's all we had for tonight. Thursday, we should be starting our program number 3, which is doing the craps game. So we'll start doing some design next class and start getting the structure worked out to do the craps. So that way you guys can go ahead and finish it. So Thursday should be a good lab. Yes, sir.
So, since that says myfunction_h instead of .h, is that actually referencing the header file?
Nope, it doesn't reference anything. This is just a name that we're creating that we hope to be unique. So a common practice is I take the name of the .h file, replace the period with an underscore, and put an underscore at the beginning and the end.
I was sitting here going, that doesn't match anything.
It doesn't. And the more common practice is to put it all in caps. So you'll see that as well. Yes, sir?
When are assignment 2 and 3 due?
I think, let me look to see what we put. I think so, yeah. Program 2 was Valentine's Day, and Program 3 was probably the last weekend of the month.
Oh, yeah. Okay, we're good.
We're good.
Yeah.
Let's see, I look at it differently. You guys look at it from... Dun, 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 dun. Program 2 was due Valentine's Day,
Cool.
and I think 3 was due the 29th, or 2 Fridays from now, or 2 Sundays from now. So
Sweet, we're good.
too easy. Any other
It's like
questions?
Valentine's Day at like 11 at night. Is that what it is?
Well, Valentine's Day legally lasts until 11:59. So, but if you procrastinate that long, you're bound to have problems. So, all right. With that said, we're done for tonight. We'll start on our craps game on Thursday.